Good afternoon, everyone. If you're a FSCP student, there's a QR code that you need to scan for your Incapath attendance. Leave that for a couple of minutes until we begin, so you can get that done. Cool. I guess we'll get started. So, good afternoon, everyone. Welcome and thank you for joining this Changing Planet seminar, which is hosted by the Grantham Industry and Imperial and run by myself, Patrick, me, and Ben, who are second-year PhD students with the Science and Solutions for a Changing Planet DTP. This is the first seminar of the new term, so I'd like to welcome the new cohort as well, and to stay up to date with our latest events. Join our mailing list to receive newsletters, follow us on social media. Ben's going to put those links down in the chat. And in particular, I would like to promote a recent feature released by the Grantham Institute, which is 9 things you can do to protect the natural world. Again, Ben will pop that in the link, but learn a few things what you as an individual can do to be nature positive. And for the seminar, just a couple of housekeeping things to be aware of. The session is going to be recorded, so please ensure that your microphone remains muted for the duration of the talk. If you have any questions, feel free to pop in the chat and we have an opportunity to ask them at the end of the seminar. So I'll call on you. It's quite nice to leave your affiliation and your name so that you know what sort of reach we're getting from the seminar. And so with that being said, I'm Patrick. I'll be chairing the seminar today, and it comes at the start of the term, which the COP26, the climate conference, is going to be held in November, and the biodiversity COP is at least being held virtually next week in preparation for the in-person conference next year. So in the light of these two vitally important gatherings, which will determine our trajectory in tackling these crises, our theme for the seminars this term up until December is going to be translating research into policy, informing outcomes and implementing actions. During these seminars, we will highlight the role of science, the decision-making process and implementation of proposed policy and monitoring of progress towards decided upon targets. And in that regard, it's my pleasure to welcome our speaker today, which is Dr. Sara Venturini, who leads the group on Earth's observations, so GEO's work to advance the use of Earth observations in support of climate action by the UN member countries and partners. She has over 10 years professional experience collaborating with UN bodies and advising governments and organizations on developing climate change adaptation policies, assessing climate finance, and participating in multilateral negotiations under the UN's Framework Convention on Climate Change, the UNFCCC, and the Intergovernmental Panel on Climate Change. Sara today will speak about Earth observations, how they can play a crucial role in the global efforts to address climate change and implement the UNFCCC and the 2015 Paris Agreement. So much further ado, I'll hand over to you, Sara, and thank you and welcome.
Hi, everyone, and thanks, Patrick. I'm so happy to be here with you today. It's a different audience from my regular community. And as you've heard, I'm the climate coordinator at the GEO Secretariat, which is based in Geneva with a bunch of other international organizations. What I do in my job really is to coordinate the work of experts in the field of Earth observations and try to link it with the national and international policy on climate, particularly to provide input to implement the UNFCCC. I have joined GEO only 2 years ago. In my previous life, I was a researcher in climate science and economics, a consultant in developing countries, and a delegate in the ministerial delegation to the UNFCCC for my government. Guess what? Italy. So all the technical questions on satellites you may have after this presentation, I'm not the right person. I've been learning a lot from colleagues at space agencies and research institutions. So really, what I do on a daily basis is building bridges between the science and policy communities, and whatever technical questions or follow-up may need to happen, I am the person who then brokers the contacts and the knowledge. Next slide, please. So as we near the end of another intense day, probably full of Zoom meetings for everyone, I'd like to start with some tranquility and calm. I never tire of watching and using this clip on Earth vital signs. This is what we are trying to preserve as we deploy and employ the science and technology of today and tomorrow. And we combine it with traditional and indigenous knowledge where appropriate to achieve the vision of digital Earth. And this is a perfectly harmonious integrated system of the Earth, where there are no visible boundaries among multiple physical systems, no visible trade-offs and conflicts in the interaction of the systems, and no country borders, really. Next, please. We know that our planet is changing. It's changing dramatically. The scientific manifestation is clear: atmospheric CO2, global sea level, global temperature, and ocean heat. Next. The impacts are also real. The human manifestation and vulnerability are everywhere: warming temperatures, longer droughts, melting glaciers, flooding and sea level rise, ocean acidification and loss of species, and stronger extreme weather. And next. But of course, our reality is much different. We all know it, and this is why we do what we do and why you study what you're studying. There are limits to what this living planet can give us to satisfy the need for scarce resources. And we are here talking about this all the time because we know that for our global village to achieve sustainability, human behavior must respect the limits and sensitivities of the environment. And this image really summarizes it well. It's from the Stockholm Resilience Center, the 9 processes that regulate the stability and resilience of the Earth system. The most recent update of the framework was published in Science in 2015, and it stated that society activities have pushed climate change, biodiversity loss, shifts in nutrient cycles, and land use beyond the boundaries into an unprecedented territory. Next. So all really is interconnected. The Sustainable Development Goals in the 2030 Agenda show us the way to address these issues across biospheres, society, and economy. In the next slide, we can see how the results of our collective work should ultimately drive coherence across policy sectors, governance mechanisms, from sector to sector, from global to local, really. Next, please. The clip I showed you at the beginning is from NASA. NASA really monitors Earth vital signs from land, air, and space, with a fleet of satellites and airborne and in situ observation campaigns. The International Space Station hosts a variety of payloads and experiments supporting climate research, weather predictions, hurricane monitoring, pollution tracking, disaster response, and much more. Naturally, it's not only NASA, but many other space agencies, meteorological offices, and research organizations in the world do that. But this is to say that we call Earth observation those data and information collected about our planet, including the atmosphere, ocean, land, and ice. And this can be collected from space or from the ground equally. The idea of coordinated and open Earth observation will enable decision makers around the world to better understand the issues that they face with regard to the relationship between human society and our environment. And this will help shape more effective policy. In the next slides, I can show you some general examples of how Earth observation are being used. Earth observation can provide localized information for assessing impacts, vulnerability and risk assessments, and monitoring of adaptation responses. Earth observation data are part of climate change science, of the foundation of science. And by observing the present as well as the past, Earth observation underpin climate modeling that help us generate more accurate climate projections by doing so. However, Earth observation are not just critical to monitor essential climate variables, they also provide actionable information to enable near-term decision-making and solutions. Satellites are particularly helpful for real-time decisions and disaster risk reduction because of their accuracy and timeliness as opposed to ground-based information. And currently, satellite can achieve really high resolutions up to 30 centimeters or even more, but I need to ask my expert colleagues. And most data products are available within 3 hours from satellite observation. Imagery are generally available 3 to 5 hours after observation, which is quite impressive. Next. But Earth observation are also used to monitor slow onset climate hazards like drought or next human activities like deforestation and land use change. And they can offer an accurate comparison of the situation before and after. Satellite data always require verification or so-called ground truthing. And that's why it's important to maintain a network of local experts and sites that can provide in situ data. Next, please. Earth observation are also used to track population growth and other variables related to society and economy, not only climate or environment, of course. And more recently, they have been used to strengthen the evidence base for the rationale of funding proposals, for instance, under the Green Climate Fund. And this has improved developing countries' access to public finance for mitigation and adaptation projects. Financial firms, insurance companies, and businesses are also employing Earth observation tools and data and products to strengthen climate risk assessment on their own assets, which creates more transparency and ultimately also drives private sector investment in climate resilience. Next, please. So finally, of course, ground-based and space-based Earth observation also provide near real-term data on greenhouse gas concentrations and emissions for carbon accounting. And this helps measure mitigation at the sectoral, regional, or global scale. Next, please. So what is GEO? GEO is an intergovernmental partnership that encourages collaboration among UN member countries and partner organizations to improve the availability, the access, and the use of Earth observation to address global challenges. We include 113 countries at the moment, but our constituency is broader as we connect the governments, UN agencies, academic and research institutions, data providers, and also businesses and local experts to create innovative solutions around Earth observations. Next, please. GEO was established in 2005, so more than 15 years ago. At the core of GEO is a work program with over 60 joint activities spanning multiple areas that are led by member countries and organizations. And overall, these involve 7,000 data providers and 4 million Earth observation data that are being organized in an accessible system and knowledge hub. Next, please. As I said earlier, we are conscious that we need to strive for coherence across countries and across levels of government. So we have set up regional GEOs to tailor our efforts across the implementation continuum to the more specific needs of regions and ultimately get us closer to national and local level needs. Next, please. GEO efforts address 4 main priorities, including climate action, disaster risk reduction, urban resilience, and sustainable development as an umbrella engagement priority. And this is done through the activities co-led by GEO members and partners, of course. Next, please. We are actively linking the GEO activities to the relevant policy frameworks, including the UNFCCC, Sendai Framework for Disaster Risk Reduction, UN Convention to Combat Desertification, Minamata Convention on Mercury, etc. And we are also producing concrete products and services to support governments, like monitoring services of agricultural crops, on impacts of wildfires, on the health of the oceans, etc. And also we are producing guidance on how to integrate Earth observation into national adaptation plans, for instance. And finally, we participate actively in international fora for global governance, such as the G7, Climate COP, Biodiversity COP, etc. Next, here are some examples of the Geo Flagship Initiatives. 4 out of over 60, as I said, there are different degrees of maturity. These ones are the most mature. They cover forest, agriculture, biodiversity, and mercury monitoring, but we have many more. And all these activities have emerged thanks to the collaboration between governments and Earth observation providers, and have received formal recognition by the respective policy framework, and that's what makes them a flagship. Next, please. So these activities that are fully operational can really demonstrate their value with concrete uptake by governments and local authorities. For instance, GeoGlam worked with the Ugandan government to predict crop failure and drought that triggered a disaster risk financing facility and saved millions of funds in the agriculture sector and lives from food insecurity, of course. And in the next slide, you can see how another activity called GeoGlows applied their streamflow forecast service to help the government manage a huge dam in Honduras during the hurricanes Eta and Iota, and again, prevented losses and damages. And I will tell you more about these stories later if you're interested. Next, please. We are also working with indigenous peoples and local communities who are essential partners in the global effort to conserve biodiversity, support climate action, and put an end to environmental degradation. The GEO Indigenous Alliance was founded by Indigenous representatives at the GEO Canberra Ministerial Summit in 2019 in Australia. We regularly have ministerial summits, and in December 2020, the GEO Indigenous Alliance hosted the inaugural GEO Indigenous Summit for the first time, which brought together Indigenous peoples from around the world to share Indigenous-led innovations in Earth observation data, science, and technology, and discuss issues of Indigenous data sovereignty and data management in support of local communities. Next. the vision of the GEO Indigenous Alliance is to really protect and conserve Indigenous cultural heritage by using Earth observation science, data, and technology to create a knowledge base that sustains the Earth that we live on, of course, involving women empowerment, education, and other important elements. Next, please. We also work with private sector partners, such as the big data service providers. We have a program in place with Amazon Web Services, which offers developing countries access to free cloud services for hosting, processing, and analyzing big Earth observation data for sustainable development. In the next slides, you see we also have a program with Google Earth Engine in place, and this has funded already dozens of projects with technical support and licenses, including by the UN Environment Program and the UN Economic and Social Commission for Western Asia. And these are all projects that involve climate change and disaster risk monitoring activities. In the next slides, you also see that Microsoft could not be left behind. So currently we are open for submissions for the GEO Microsoft program. It's an open invitation to be among the early adopters of the so-called Microsoft Planetary Computer. This is a multi-petabyte catalog of global environmental data with application programming interfaces and intuitive applications. So the winners will be able to help shape the development of this platform in the early stages, and they can also utilize open data and analytical tools by doing so. And this program will support concretely a number of projects over 1 year that use the planetary computer to apply Earth observation to address environmental challenges. And you can find all the information on the GEO website at the link I gave you. Next, please. One thing that we do well is to engage the community. As I said, it's a big community. Normally, we would do this in person. And we have our regular GEO plenaries, events, sessions as all the UN agencies. The GEO Climate Workshop was the second of its kind in all GEO history. So climate policy and finance topics are pretty new to the GEO community. So we were really pleased that hundreds of participants joined the workshop that was held over 3 days from the 21st till the 23rd of September, 2 weeks ago. And the workshop discussions really highlighted what GEO activities and partners are doing to support national action on climate mitigation and adaptation, and to assess progress towards reaching the Paris Agreement's purpose and long-term goals. And this has provided GEO with a broad endorsement to further work to identify its unique contribution to enable climate action and the value added in the Earth observation community, which is made of many actors, really. And this is aimed to get an official mandate to deliver under the UNFCCC. Also, the workshop has raised awareness of how Earth observation can contribute to strengthen the evidence base for public and private investment decisions on climate action by providing an overview of ongoing initiatives by development banks, financial firms, and insurance companies that involve Earth observation. There are many more than you can think of, and most of them are based in the UK. With that, we officially launched the GEO Climate Finance campaign or workstream that will be implemented next year with more hands-on workshop and targeted engagements. Now, I'd like to give you only some insights of the discussion with the time we have today, but you can find all the recordings and workshop materials on the GEO website, and we hope that we can engage you as well in the next activities. So in the next slide, to start, I'm assuming that you are all familiar with the UNFCCC, but perhaps only a few have followed the topic of Earth observation within the negotiations. It's a very specific work stream, but it has foundations in the convention itself. So Article 4 on commitments says that governments must promote and cooperate in scientific, technological, technical, socioeconomic, and other research, as well as on systematic observation and the development of data archives related to the climate systems. And this should be aimed at eliminating the uncertainties regarding the causes, the effects, or the magnitude of the consequences of climate change and the response strategies. Also, Article 5 says that the countries must promote and cooperate in systematic observation of the climate system and exchange information. And this is also an obligation to support and strengthen systematic observation and improve capacity, particularly in developing countries. And as you know, only developed countries have obligations under the UNFCCC. So as you can see, Earth observation play a key role in addressing climate change as a foundation to the work of the UNFCCC through a value chain, which includes observations, research, and the IPCC assessments. And this image shows that products of this value chain support action taken by parties under the convention, and they are also direct inputs into decision making. So data and information for climate action generated by Earth observation providers like GECOS, the Global Climate Observance System, CEOS, which is a Committee on Earth Observation Satellites, so the coalition of space agencies in the world, WMO, the World Meteorological Organization, and GEO and others. These data can be better optimized through applied climate services that are also supported by other institutions like GEO, WMO, Global Framework for Climate Services, Copernicus, and others. So it's a really interesting way of seeing how the Earth observation are embedded in the policy of under the convention. In the next slide, you can see another image that illustrates the Paris Agreement mechanism. Starting from the top left, countries provide a national climate target every 5 years. They are nationally determined contributions, but must be stronger than the previous years, the previous targets. And countries also communicate individual efforts on national adaptation processes. Starting in 2024, countries will report on progress to achieve these targets, and reporting will take place every 2 years. So these are called biennial transparency reports. And countries must use these reports to indicate by how much they manage to cut greenhouse gas emissions in relation to the national goals indicated in the NDCs. Reporting is more flexible for developing countries, of course, but all countries should move towards stricter reporting over time. And an international assessment called the global stocktake happens every 5 years to consider if national pledges have been implemented and whether there has been collective progress towards the goals of the Paris Agreement. So naturally, for mitigation, there is a clearer target, which is quantifiable greenhouse gas emission reductions to keep global temperature in check. While for adaptation, it is more difficult because building resilience is a moving target, and it's also very much context specific. So through this stock-taking process, recommendations and ways to be more ambitious in the next cycle are put forward, and countries take the recommendations and their experiences home, and then provide more ambitious targets in the next 5-year cycle. So here, really the point here is that Earth observation and the data community can support climate action on two levels: directly supporting parties and supporting the global process under the UNFCCC at the international level. So in the next slide, you can see some options to support countries in their national action on climate change through Earth observation. These include increasing the capabilities of governments to implement mitigation and adaptation action. Of course, in particular, this means refining tools and methods to increase the quality and decrease the uncertainty for national greenhouse gas inventories and for the identification of emission hotspots. Also, there is a need to identify indicators and other climate services that could support adaptation assessments and monitoring that can be then incorporated into the adaptation reporting cycle. In the Earth observation domain, there are opportunities also for linking technology, capacity building, and finance to support countries' capabilities for action. And also Earth observations are a way to integrate approaches with SDGs, Sendai framework, and the other Rio conventions. And finally, the Earth observation community is invited always to provide case studies and report progress to the dedicated body to inform the negotiations. Next, at the same time, the Earth observation community can support the international level. So the global stocktake is designed to assess the progress towards the purpose and the long-term global goals of the Paris Agreement, as I said. Therefore, this will be done along certain thematic areas for collective progress. You have to remember the word collective, as opposed to the individual reporting submitted by countries. So what they really want to measure here is the aggregate progress for mitigation, adaptation, and finance flows and means of implementation and support. And also there are some cross-cutting issues that are also including, for instance, loss and damage, which is not a minor issue for sure. In the next slide, you will see that the global stocktake will be implemented in stages. For the first time will happen in 2023 and every 5 years thereafter, but the collection of input from various sources and the related assessment to prepare and inform the global stocktake has already started this year. So this phase goes from November 2021 until June 2023 and will focus on gathering, compiling and synthesizing information and preparing for the subsequent technical assessment component. The technical assessment phase will focus on taking stock of the implementation and assess the collective progress on the key areas. This will then be followed by the consideration of output, which will be the final component of the global stocktake and will really try to discuss the implications of the findings and the action needed by governments. The overall global stocktake outcome is meant to inform parties to then update and improve their NDCs and international cooperation for climate action, which also includes Earth observation. So currently, the UNFCCC Secretariat has revised a thing called non-paper that includes all the guiding questions that should be addressed in the global stocktake. And this is the link I included in the slide. And these questions are also meant for the Earth observation community, so GEO and all the partners who are involved. Next, you can see a helpful or rather confusing scheme of the global stocktake process that you can find on the UNFCCC website. It has been updated recently. It's a learning process also for the UNFCCC And there will be a lot of adjustments as we move forward. Next, please. But what is important here is that to provide input to the global stocktake, an ad hoc coordination group of the systematic observation community has been established at the end of 2020. And of course, we are part of it, national space agencies, WMO, and many others. And we are discussing how to measure and report collective progress using Earth observation. So this is a big deal now. Currently, Earth observation is only used partially for reporting purposes or for mitigation and adaptation, but has a much bigger role going forward. And in particular, the UNFCCC is expecting information from the Earth observation community on mitigation. So how Earth observation are observing greenhouse gas and temperature trends and projections, and the support to parties for the greenhouse gas monitoring and reporting through Earth observation using satellite information, notably. On adaptation, there is an expectation that Earth observation can provide information on observed or projected impacts and risk, and information or indicators, global indicators for and on adaptation to measure global progress. For means of implementation, there is a need for the state of progress to support developing countries for finance, capacity development, and so on. For cross-cutting issues, it's a general request to see how we are working to support nationally determined contributions or national adaptation plans, and information on loss and damage that is mostly managing risk in this case. So GEO is already supporting countries in a wide range of mitigation and adaptation tasks, and I'm going to give you some examples. Next, please. So first, I'd like to focus on the national level. From the workshop discussion with country representatives, it emerged that Earth observation needs vary for least developed countries, small island developing states who actually prefer to identify themselves as big ocean states. Also, remote mountain nations, indigenous people, and local communities all have different needs. And there are also several challenges around these needs. So first, policy. It is crucial to enhance open data policy and national policy on climate and disaster-related data. This is something that GEO members must endorse, open data. Secondly, coordination. There is a generally limited coordination and information sharing between institutions in countries and regionally. Thirdly, fairness of data and risk assessment. There are difficulties in centralizing, securing, and sharing different types of data across institutions. In terms of resources, developing countries, of course, cannot afford high cost of data collection and processing, hence why we collaborate with cloud service providers, for instance. And finally, knowledge. In general, there is limited awareness, capacity, and capabilities for using Earth observation and data, and this is another field we're working on. In the next slide, I would like to present a concrete story to illustrate the power of Earth observations to overcome some of these challenges. The case study is based on the work of the Group on Earth Observation Global Agriculture Monitoring, GEOGLAM. And as indicated here, a crop monitor for early warning is produced monthly for almost all regions of the world. The partners include the International Food Security Community, World Food Programme, FAO, etc., and several national food security ministries. This is an example for Africa from the September report. The map is based on Earth observation data, agroclimate, and the assessment of regional experts. The process looks at all information and comes up with a consensus product. And this consensus is essential to its acceptance as this becomes an authoritative source of information in the country. Next, please. Over time, the information going into the reports has expanded beyond just Earth observation. It now includes conflict reports, locust updates from the FAO, and as seasonal forecasts improve, they are being used more and more to improve the outlooks as well. Next, based on the success of the crop monitors, GeoGlam began working with national ministries in least developed countries to co-develop their own crop monitoring systems. What we found was that as countries develop their own capabilities, the information is trusted and can be quickly turned into a proactive response and policies and programs. So far, there are 7 countries, 7 national monitors, and 1 regional monitor for the Horn of Africa. And I will now focus on how co-development of these national systems can contribute to climate adaptation using our example from Uganda. In the next slide, you can see that we're talking about the Uganda experience. So households in Uganda face considerable climatic risks, primarily related to drought. The predominantly rural population mostly consists of smallholder farmers who are subject to several production constraints and have limited capacity to cope with recurrent climatic shocks. So a region called Karamoja is particularly vulnerable to food insecurity due to poor or sporadic rainfall, and is highly exposed to droughts, with more than 80% of the households relying heavily on low productivity and rain-fed subsistence crops. So the disaster risk financing project provides additional support to households in the Karamoja region immediately following crop failure triggered by an agricultural drought event. And support takes the form of a temporary expansion of labor-intensive public works activities to offset the loss of food production. And to ensure that additional resources are released as quickly as possible following the onset of a drought event, the disaster risk financing funds are triggered automatically using objective, pre-agreed and quantitative indicators that were built by GeoGlam, working together with the Ugandan government. So in this case, these indicators are key. Satellite-based remotely sensed data can be used here to achieve the goal, and these are considered much more reliable than rainfall data with no gaps in geographic or time coverage and very small delay times in obtaining the data. And that's why it's important to highlight the role of Earth observation here. In the next slide, this nicely sums up the impact Earth observation had on the disaster response with the quote from the Ugandan Prime Minister's office. Essentially, the Earth observation-based crop monitoring provided 3 months early warning, enabling proactive response before the full effects of the drought were being felt. And in disaster response, early warning is key, particularly for slow-moving disasters like drought. Another win is that the simplicity of the framework and access to the GeoGlam system made it possible to run the crop monitoring locally, increasing not only the credibility of the analysis, but also the ownership, which really helped sustain the decision-making flow. Next. So really quickly enabling the DRF program allowed public works fund to offset for production losses, improving the outcome for about 300,000 people, more than 66,000 households. But not only did the quick response reduce human suffering, but it did so while saving significant funding resources as well. And based on the success of the crop monitoring, the Earth observation-based monitoring is now an operational part of the Ugandan National Early Warning Bulletin. Next. So we are now building on, the one before. We are now building on our experience in co-development to create supplemental technical guidance for NAP processes under the UNFCCC, using practical examples from the Ugandan experience. And the guidance that we are working on will address the utilization of Earth observation for the development of the NAPs and moreover focus on how it can be used to achieve the long-term adaptation goals through early warning and in the agriculture sector. So I would also like to acknowledge the support of UK DEFRA that enabled much of the work by GEO and GeoGlam leading up to the NAP guidance that should be released very shortly. Now, another success story in another part of the world, the GeoGlows initiative brought together experts from everywhere to create a global streamflow forecast that is freely available, providing actionable information as a service to places where little or no services exist, and filling gaps that can complement and strengthen national, regional, and local efforts. Next, the GeoGlows Streamflow Forecast Service is an application of the Global Runoff Forecast from the European Centre for Medium Range Weather Forecast, ACMWF, that transforms runoff into river discharge forecasts for every river of the world. And organizations from these countries, including hydromet services, disaster preparedness and response organizations, national hydroelectric companies, food security organizations, and many others are among the users and stakeholders of this service. Next, as you know, climate change is making Atlantic hurricanes more dangerous and damaging, and Hurricane Eta and Iota were the third and second strongest November storms on record in the Atlantic, respectively, with peak wind speeds of 150 and 160 miles per hour. From the dates marked in this slide, note that there was about 14 days between the two storms. Next, in the Sula Valley is where the hurricane hits, and it is the area with the highest agricultural and industrial productivity in Honduras, which requires a high workforce concentration. The valley is also one of the most vulnerable to flooding. The only major river control structure in the basin is the El Cajon Dam, officially known as Central Hidroeléctrica Francisco Morazan, with about 39% of the water contribution to the valley. And the National State Power Company, NE, manages this massive hydroelectric dam and is responsible for the generation, distribution of the electricity in the country. So during the emergency caused by the hurricanes in their passage through Honduras, the priority of the National Electric Energy Company was to safeguard the life of about 23% of the country's population, and to minimize the potential economic losses in the valley, which generates 65% of Honduras' GDP. Next, in preparation for ETA, the company accessed usual forecasting tools already available, which had a horizon of 6 to 24 hours, or another one would forecast up to 3 days. Next. And with the traditional information available, as part of the company's management during the storms, the energy production was maximized while retaining as much water as possible in the reservoir. And this action really controls some of the upper basin water flows and decreased flooding in the Sula Valley, but complications were brought by the Hurricane Hita's destruction of the limited ground station that provided the usual guidance to decision makers. Next. Then the announcement of the second hurricane came. The information from the traditional models was insufficient to determine a long-term management strategy to estimate the volume of runoff that Iota was bringing 13 days later. Next, and through collaboration with the regional AmeriGeo, the energy company became aware of the forecast service provided by GeoGlows, which is a 15-day forecast service provided directly from the web for free. In the next slide, you can see that in situ data was used to determine the accuracy and skill of the stream forecast and to decide whether or not the company's decision-making process could be based on the GeoGlows forecast. So this was quite efficient. And in the next slide, by November 12, the company decides to use the GeoGlows forecast information and develop a reservoir management plan. So with that, the priority was to make room and recover reservoir storage capacity. And with the new information, it was decided to release a series of water releases while following the discharge protocols. Next. In addition, this analysis provided the confidence to make decisions on November 17 in the middle of Hurricane Iota. At that point, the company has also decided to close the gates to detain the dam's inflow, so to not add the extreme flows to the extreme flows of the rivers and provide the best opportunity for the flood wave to pass through the Sula Valley. Next, so comparing the analysis developed by the Economic Commission for Latin America and the Caribbean, the losses in the 2020 caused by the two hurricanes, Ita and Iota, which were around $2 million US, were lower by 40% than those from Hurricane Mitch in 1998, which were around 4 million. Certainly, some of this reduction was due to the implementation of disaster risk reduction measures immediately following Hurricane Mitch. However, considering that the El Cajon Dam is the only structure in place that is capable of controlling this massive volume of water in the Sula Valley, we can say that the GeoGlows information has hugely helped the management of the reservoir during the hurricanes and prevented losses and damage. Next. Now, I'd like to go back to the overall process. These were just two examples you've heard. There are many more activities that are active in different sectors, including wildfire monitoring, forests, coastal zones, mountains, etc. But some activities in GEO are also starting to consider how to support the global stocktake, which is a new area that requires a different set of products. As I said, it's aggregate measurements that they're looking into. On this point, I maybe should give you just an overview of the capabilities to monitor global greenhouse gases, which was preliminarily presented at the workshop 2 weeks ago. Next, please. So in December last year, there was a forum on innovation in remote sensing technologies for accelerated climate action that involved the former US Vice President Al Gore and the UK high-level action champion Nigel Topping. And one clear outcome of this event was the need for an improved understanding of how Earth observation can contribute to national greenhouse gas inventories and the global stocktake by providing a full picture of currently available and upcoming greenhouse gas monitoring capabilities from space. So at that time, only a registry of public missions existed, maintained by space agencies, but there was no clear picture of what private sector was doing. So over the past months, GEO, the World Geospatial Industry Council, which is a business association for private sector, and Wartime, which is part of the Climate Trace Coalition, have been collaborating to develop the first comprehensive database of relevant satellite missions that monitor greenhouse gas emissions, including from space agencies, commercial initiatives, and public-private partnerships. So a joint report is being finalized and will be published before COP26. So the objective really is to build the bridge between the data providers and the ministries so that they know what's available out there to do their greenhouse gas reporting under the convention and the Paris Agreement with novel technologies. Next. So working together, we consolidated the different information sources to create the new database. We relied on existing database from CEOS, the Committee of Space Agencies, and mission websites, peer-reviewed articles, etc. And we have identified around 40 past, ongoing, and upcoming missions relevant for measuring greenhouse gases established under the UNFCCC. And the missions have been qualified by status, mission goal, which greenhouse gases are observed, scale of application, and 3 general scales used: point source, national level, and global level. And also data access, which is either open or paid subscription, registration required, etc. And lastly, we collected all the relevant information for each mission. In the next slide, you can see some preliminary findings. The first chart is mission status by country, meaning a breakdown of missions that are in orbit and currently collecting data and in development. And these are represented by the green and yellow color bars. Additionally, we included a breakdown of missions ownership with blue, red, and purple color bars, and how many are being developed by each sector. You can see, as expected, that the public sector represents the bulk of the missions that monitor greenhouse gas currently in orbit in the green color bars, and there is a lot of activity in the public sector with future missions as well. In some cases, commercial initiatives and public-private partnerships in red and purple represent all or the majority of future missions for specific countries or joint efforts between countries. The second chart on the right highlights the number of missions monitoring specific greenhouse gases and by sector, both in orbit and planned. So the public sector is strong in monitoring all greenhouse gases at the global and national level, while the private sector does monitor all 4 greenhouse gases in some capacity, but there is more specialization towards monitoring specific gases such as methane. And the hybrid missions are similar to the private sector. Not highlighted here, but worth mentioning, the private and hybrid missions are directed more towards point source monitoring of emissions. In the next slide, we have a preview of the key messages that will come out of the report. Essentially, satellite observations reduce uncertainty in the greenhouse gas emission monitoring results, of course, because they provide more accurate, more timely information with higher resolution across a range of spatial, temporal, and spectral scales. And it's important to clarify that currently national greenhouse gas inventories submitted by parties to the UNFCCC use bottom-up methods. These are essentially inventories that are made using estimates of annual greenhouse gas emissions and removals made through National Statistical Office's data per sector. And there are also top-down methods that involve, estimates from measurements of greenhouse gas atmospheric concentrations determined in space and time that are made using Earth observation data that then feed into climate models. So these are called top-down atmospheric inventories. They are not as process-specific, but they are more accurate, and they complement those methods by providing additional data sets on a range of scales. So that's why it's important to include satellite information in the inventories. Secondly, government space agencies are collecting national and global baseline data, and in doing so, they are providing they have already monitoring capabilities that quantify a global total for CO2, which is helpful for the global stocktake, while they're only beginning to trace CO2 and methane in a way that is complementary to the ground-based network. So space agencies are committed to providing demonstration products for the first global stocktake with a view to improve their offering and include significantly more accurate information on greenhouse gas emission in future global stocktakes. The private sector companies are increasingly entering the market. You must have heard a lot in the news. Private companies have been driving innovation around especially point source emissions, for instance, greenhouse gas peaks and leaks for methane especially. And this can also contribute to the global stocktake by providing complementary and high precision data on greenhouse gas emissions, since most greenhouse gas emissions that cause climate change come from a limited number of very large point source emissions. Fourthly, hybrid models are increasingly emerging and strengthening the existing partnerships and strengths of all the partners involved. Collaboration, innovation, and financing are key levers for greenhouse gas monitoring from space, and there is need for more collaboration and more financing to help countries develop more accurate NDCs and reporting. Open data, open science, and open knowledge are essential to drive on-the-ground solutions. And finally, new opportunities are arising for analyzing secondary remote sensing measurements with artificial intelligence, machine learning, etc. And this has been done, for example, by collecting Earth observation information from multiple sources, as well as companies' assets data, and combining them and analyzing, applying big data analysis, etc., and independently estimate greenhouse gas emissions. But here there's a question of trust, whether countries would accept these independent evaluations, of course. In next slide, now I've discussed a lot of greenhouse gas monitoring, but I should mention that Earth observation on agriculture, forestry, and other land use are also important to measure biomass and in turn to calculate greenhouse gas emission and sinks. And for adaptation, there are efforts ongoing. As I said, it's more difficult to measure adaptation at the global level, but there are ongoing initiatives to identify global adaptation indicators starting from existing experiences like Geo Blue Planet, Global Eutrophication Indicator developed to measure SDG 14, or GeoBon with essential biodiversity variables, or Geo-Human Planet with essential societal variables. And all of these could potentially be applied in the context of the global stocktake. And it's also important to consider the very political issue of loss and damage. Earth observation support early warning systems, as we saw, and parametric insurance that are part of the risk management component discourse under loss and damage. And finally, consideration on how Earth observation are used to support climate action by Indigenous people must be included. For instance, there is a new program launched by Norway, International Climate and Forest Initiative, that essentially helps removing bottlenecks by making data available to all free of charge for forest monitoring, which helps detect illegal logging, helps monitor forest areas, and document land rights for Indigenous people. And all of this will be included in the synthesis report by the Earth observation community to inform the global stocktake to be submitted in February 2022. Next, and almost final slide, sorry for running a bit over time. The Earth observation community, of course, will be at COP because we participate in the SABSTA, subsidiary body for scientific and technological advice, in particular, the research and systematic observation negotiations. Under this work stream, since a few years, there has been a mandated event called Earth Information Day. And this is happening on November 3rd. The official segment is organized by the UNFCCC Secretariat and will set the scene, linking the science and policy makers and demonstrating the power of Earth observation. And there's also a COP26 presidency, so UK-led segment of the Earth Information Day. And this will also take place on the same day. To further showcase experiences mostly from the UK, but also public-private collaborations involving Earth observation, so it should be interesting. And there are also other numerous opportunities to highlight the role of Earth observation for climate action across the 2 weeks. And these include a demonstration of Earth observation applications and solutions in the blue zone, in the green zone, and other showcasing spaces across Glasgow. And these are in line with the COP26 presidency theme days. And I should flag there is a Geo Indigenous Alliance event in the Green Zone on November 9th. And we have prepared a brief for UNFCCC delegates who want to know more about Earth observation. Next, so to close on a light note, we also have an Earth observation and art competition open these days. And final slide, I invite you to check our website for this. And in the next slide, I have indicated the link. There are other opportunities. We are also hiring new experts in the Geo Secretariat very soon, and we need brilliant minds like yours. So thanks for listening patiently. I'm now here for questions, but remember, I'm not a satellite expert. And thank you very much.
Okay, brilliant. Thank you very much. So that was great. So much to know about observations, how it informs policy, how you can use it in real time to sort of respond to disasters effectively. It was really interesting. We can start with a question. I know Jeff has many in the chat, but in the interest of time, could you condense a couple into a single question, and then maybe you get time to come around to another one? If you would like to ask your question.
Oh, okay, thank you. Well, I'm not sure because Dr. Venturini said she was not a satellite expert. So I was really interested in the data that's been accumulated. I'll give two different types of questions then. I'll condense. One is if Dr. Venturini, if you are familiar with the data, you can cover that. If not, I have that's more on the politics and stuff or the reliability. I would like to know how good the data has been in forecasting potential disasters, and also how sensitive it is. For instance, can it localize urban heat islands? Can it localize migration of exchange of mosquitoes? And is there a group within the organization that does analysis like a domino effect? So if they find a local area that's soon to be predicted to be a drought area, can the group then say this will affect an area 500 miles from here in this way, this will affect an area further away in this way? If those are too technical, can you still hear me?
Yeah, I can hear you.
Okay, thanks. I saw a monitor change. If those are too technical, then I would like to know how reliable, now that there are so many satellites missions, one of the things one wants to know is not only is it better than the ground-based missions, but how reliable are they in accuracy? So when you compare one satellite's measurements with another satellite's measurements, for instance, ozone in a local part of the atmosphere, are they aligning themselves so that the reliability of the different missions can be trusted, or is there a lot of variability in the different mission findings? Over. Thank you.
Okay, thanks. There's a lot of questions that I try to address. I think I can certainly respond to most of them. In terms of reliability of satellite information, as I said, currently a satellite can achieve a resolution up to 30 centimeters, which is a lot to measure climate impacts. And so this allows, of course, measuring local heat island effects, information on local biosphere, and most data products are available within 3 hours from satellite observation, and imagery up to 5 hours after observation. So it's really, really helpful tool for real-time decisions and disaster management because of their, timely services. And this is what has been going on for, wildfires, flooding, many other products. In terms of domino effect, so yeah, that's a good point, of course. Currently, it looks like our activities are a bit working in silo, and there's probably one that tries to summarize the impacts, to try to sort of see the big picture, but it's doing this from the SDGs, from the Sustainable Development Goals point of view. We should, talk with the expert to see what exactly they are doing. But this is a question that, of course, requires a team of numerous experts. But you're right. This is something that it is encouraged in international cooperation. The point on greenhouse
How about
gas,
the variability of different missions?
Yeah.
Is the data lining up so that you can't say, well, the data are all over the place? If two different satellites are measuring the same area of atmosphere for ozone or for methane, are they in sync? Is the variability low?
Okay, so normally the variability is very low, but the data may differ for sure. And these satellites are being used by individual countries for their own reporting. Now there is this coordination group, as I mentioned before, on working on providing input to the global stocktake. So the global stocktake will require this aggregate figure that you're talking about. So there needs to be a sort of consensus agreement among all the data providers from national space agencies. And this is the difficult part because, of course, Of course, instruments are different and measurements are different. But for instance, in the case of GeoGlam that I presented before on agriculture crop monitors, this is also an example of how this works. You have satellite information, but you also need ground truthing with verification from local experts. So it is indeed a consensus statement what comes out of this exercise, and it needs to be the same for greenhouse gas monitoring for the global assessment. I hope this clarifies a little bit, but of course
yes, thank you very much, and thank you for an excellent and informative talk. Thank you.
Thank you. I can put you in touch with the expert from the GEO activities if you want to know more about the specific work.
Can you say the expert's name, and then I can search on it?
No, you tell me which it's the other way around, because there's too many, and if you tell me which
okay, I have your email that you put out, so yeah. Thank you.
Okay, brilliant. Thank you for the question, Jeff, and Sara for answering it. We have a hand up from Lisa quickly. I think this might be the last one if we get on with time. So Lisa.
Yeah, hi. Here, I'll let you see what I look like, I guess. I'm a grad student at San Jose State, so I don't have, and I'm in materials engineering, and so I don't really have a horse in this race other than being a human on Earth. One of the things that we're observing here in the US right now is a great deal of pushback and political turmoil around simple, small things like wearing a mask for COVID. And I have also seen situations where someone developed a new product for tracking, using RFID to track sponges in a surgical suite so they didn't get left in a body. And it was resisted by the nurses, surgical nurses, who felt that counting sponges was a vital part of their job. And so if they were afraid of being obsoleted. Are you finding with any of, and of course, Trump was like, oh, if we test for COVID, then that will make me look bad. Are you finding that there are politicians or entrenched corporate groups, loggers or something, that are giving you pushback for the wider use of the satellite adaptation for monitoring? And what can you do about that? I'm just thinking, if you're not seeing pushback, you could develop pushback, and maybe looking at some of these other cases can help you get ahead of that. Mm-hmm. But anyway, go ahead.
Thank you. That's an interesting question and point of view. In fact, there was some resistance in the beginning to abandon, the usual policy of keeping the available satellite data to themselves. By countries. So that's why GEO exists, in fact, because we want to push for open data policy. So the countries that adopt satellite technologies are also now willing to share the information collected, the data collected, which is a great starting point for not only for those countries, but for the other countries that may not have available technologies, especially in the developing world, but need those technologies to implement adaptation and mitigation actions. So I wouldn't say there is pushback to use satellite information. There is only lack of access or capacity in developing countries. And this is what we're working on. Hopefully will be resolved through international cooperation.
Okay, one more. Are you finding that the providers of satellite data are doing any kind of hoarding or sitting on access? Because that's another thing I've observed in terms of like general corporate versus government corruption, is that someone will gain control over access to a resource and then use that as personal enrichment source rather than whatever their original authority was supposed to be. Are you finding any of that? And I'll shut up after.
Thank you. No, so from the government level, no, the countries are now even if there was some resistance in the beginning, maybe from China and others, and now they have opened the doors to, data sharing. There is a different issue now with the emergence of private missions, commercial initiatives that own data and then ask a fee to use the data. So in this case, what's important is that countries step in and provide, incentives or ways in which data are becoming also available to everyone, like the example from Norway for the forest monitoring. So I think, this is happening to some level, but it is manageable, I think. Okay.
This is Jeff. I have another one. This is Jeff Greenspan, but I'll accede if someone else has one, since I've already asked.
Any other questions? And then, there might be the last question from Jeff. Go ahead.
I was impressed by already the number of missions that have been sent up already. It occurs to me to ask, is there any regulatory agency that coordinates the missions so that they're done efficiently? You need a certain amount of redundance to verify initial measurements. So you would like independent measurements more than once, but you don't want it done 50 times in one area and 0 times in all other areas. So is there any attempt to have some agency that coordinates or gets cooperation from the different nations and organizations to send up missions that are the most efficient in providing the data needed? Over. Thank you.
Yes, indeed, this is a big area for international cooperation for countries. There's a lot of money involved and a lot of interest. And there's a Committee on Earth Observation Satellites, CEOS, that coordinates all the missions from space agencies in the world. So they develop a joint roadmap and an implementation plan for the upcoming missions, so they can, as you said, make sure that there are no too many overlaps, and the missions are mutually helpful and cover all areas and all sectors, that even the emerging sectors or issues like the global stocktake, et cetera. So these are all issues being discussed within this CEOS coordination.
Thank you.
Okay, brilliant. Thank you. It's just come to my attention that there is another question from Anna G, who was asking about the analysis during the hurricane. If you'd like to ask the question.
Hello. Hi. Yes, I was just wondering, with the analysis of data for the hurricane in Honduras and the fact that that was done in real time, did they just provide the data and then it's analyzed by someone else, or do they do the analysis as well for that?
Normally they should do the analysis, and data that are provided to the government are decision ready data, and that's what they're trying to do with many other products in GEO, because of course raw data are of no use to government officials or private companies, and there needs to be an intermediate step to analyze the data, and so that's the full package that's provided.
Okay, is there any kind of capacity building within countries to be able to have the expertise to be able to analyze data themselves?
Right, that's another big question, and this is what GEO should do, and what countries are here for. They cooperate to build capacity in countries to be able to use properly the data that are made available. We're working on it, and there are some initiatives that already embed capacity development in their programs. Others are less so, but this really affects the ownership of products and the uptake by decision makers, as you can imagine. And but it's normally done with targeted investments, and it should be done more, if you want my opinion, of course.
Thank you.
Okay.
Dr. Venturini?
Yes.
Thanks. This is Jeff Greenspan again. It was very interesting to see the specific examples that you gave for intervention in preventing disasters and stuff. The kind of data you're generating are going to be used for immense socioeconomic changes and lifestyle changes. Are you running into any resistance from local populations in accepting the need for change based on the data? And if you are running into resistance, can you generalize, if possible, what types of populations are resisting you, and what that kind of data, and what type of populations are accepting that type of data for their socioeconomic changes? Thank you.
Right, that's a tricky question. I would say that in general, I haven't heard of any resistance to adopt, new technologies that improve, in fact, the decision-making process, provided that they are, accessible and given for free or for the right price.
Not necessarily the technology, but you're going to generate technology, and based on that, recommendation to be made that are very profound. It may be you need to migrate to another area. It may be you need to raise your house a certain number of feet. It's not the resistance to the technology. It's weighing the cost and the benefit. Are you finding any populations saying we're not sure the data is good enough to justify making this momentous move? What will make people to trust the data?
Exactly. That's a big question. In fact, yes, as you can see, you can read in the news, people sometimes they keep, investing in buying houses next to coastal areas that are going to be flooded for sure, because data say so, and because we see that already happening. So this kind of resistance is there. What would it take to win this resistance? I'm not sure if even with technology and demonstrations we can do that. I hope that we can convince people before a disaster happens. But there's a lot of work that the international community needs to do in terms of raising awareness. A lot. It's a lot about communication. Many people, like for COVID, they don't really understand the risks, and we can only provide facts. But then it's up to individuals to implement change.
Thank you.
Okay, great. Thank you, Jeff. I think we're going to close the Q&A there. It's getting to past now. So I'd just like to thank Sara again for an amazing conversation and a good discussion afterwards, and all the people who asked questions for contributing to it. Just to let everyone know, the recording will be out on the Grantham website, social media and stuff sometime soon. We'll probably send out email and post that. And yeah, I think that's all from us. Give a thank you to Sara, of course. And end it there.
Thank you.
Thank you.
Thanks so much.
Bye.
Very good session. Thank you.
Thank you.